Hello, my name is Brian Palaszewski of the NASA Glenn Research Center in Cleveland, Ohio, and my presentation today has to do with what we call massless exploration, which is an extension of in situ resource utilization. And our presentation will discuss some work that we did a number of years ago at the request of NASA headquarters to explore ISRU in a more detailed fashion. Just as an overview, we'll discuss massless exploration and its link to ISRU. And our program here was designed around 4 sprints, or 4 different ways of using in situ resource utilization to help human expansion across the solar system. The first was a lunar colony. Next, a Lagrangian point hub. Next, Mars exploration, including Phobos and Deimos. And then finally, Jupiter with human missions to Callisto. And of course, we'll talk about some observations and concluding remarks. Now, the key drivers in this massless exploration set of sprints included numerous things, but we'll only discuss a few. One is to benefit the people of Earth. One is to establish homesteading, that is to lead to future human colonization of the solar system. And of course, answering the big questions to better understand the nature of the universe. Other key drivers are the enabling of the human expansion into the solar system. Also, we want to develop a spacefaring citizenry and also understand ways to allow people to work and live safely beyond the Earth in sustainable ways. Another, and perhaps and most important, is the recovery from a cataclysmic disaster that may occur with the Earth's collision with an asteroid or a comet. And space colonies can provide cradles of humanity to assist in the recovery from such a disaster. This illustration shows the beginnings of a potential lunar colony. You can see in the center photograph there is an inflatable structure into which several decks have been created for a comfortable living environment on the surface of the moon. The idea here is to start small and then build up to a capability to provide a number of humans on the surface of the moon, including rovers and hopping vehicles, and resupply perhaps from the Earth. The first element might be a series of robotic assembly vehicles that would help with the creation of habitats on the moon using in situ resource utilization. A number of tasks have been discussed and analyzed in some detail on how the lunar regolith can be modified to create construction materials for these habitats that would protect astronauts and vehicles from the harsh lunar environment. Also, these vehicles can be used for exploration and the extraction of resources using in situ resource utilization. Here we're discussing a Lagrangian point hub. This is a place where would be in the Earth-Moon system that would be a meeting point and a place of commerce where humans could live comfortably in zero gravity, or perhaps in some form of artificial gravity. And this hub could be a way station where propellants created on the surface of the moon from water caches or lunar oxygen. Those propellants could be stored on the Lagrangian hub and be used as a place of commerce to trade the propellants for other materials. Here we see what could be a pressurized construction and maintenance transport vehicle. So a human being who's doing construction of the hub would not have to be exposed to micrometeoroids and would be in a shirt sleeve environment that would make things more comfortable for the astronaut during these construction tasks. So this would be a potential way of creating this hub that we're discussing in a libration point. There's 5 libration points in the Earth-Moon system, but L1 and L2 seem to be the most attractive for transport from the surface of the moon, although L4 and L5 are potentially more stable locations in that Earth-Moon system. This sprint represents Mars exploration, which also includes the 2 moons, Phobos and Deimos. Mars, of course, has rich water resources that have been discovered by a number of spacecraft that are under the surface of Mars, frozen there. So we're very excited about the possibilities of human colonization of Mars. Also, the moons are of particular interest because of their unusual nature. This image shows a electric propulsion vehicle that's going to rendezvous with Phobos and Deimos. So with these moons, we can use their resources, which may include water and many other metals and minerals, and allow us to also understand the Martian origins of these moons. The last sprint had to do with human missions to Jupiter. Here we show a nuclear electric vehicle that is performing human missions to Callisto. There are a number of different vehicles that would land on Callisto, including a vehicle carrying a nuclear reactor, one with an in situ resource factory, and a last one carrying humans to the surface. Now, in this analysis that was done, both fission-powered nuclear electric vehicles and also fusion-powered vehicles were investigated. And certainly new technologies might also supplant those designs. In this chart, you can see an encampment on the surface of Callisto for human exploration. Here we have several vehicles that have landed. There's a nuclear reactor, there are a number of rovers, and there's the human landing and ascent vehicle. And the icy surface here would be set up with the reactor to power the human encampment. And in this plan, the humans would be there for about 1 month on the surface. Now, there's also strong implications that there's a subsurface ocean on Callisto, so there is the possibility in the future of supporting a much larger human colony there with the water from that ocean. Certainly also there's the idea of which pieces can be provided from Earth and which pieces can be made in space. So we created this chart that illustrates the fact that reactors might be built on the Earth, as well as electronics, but things like structures, food, and propellant certainly can be made in space. And of course, there are hybrid elements where we have spacecraft that can be partially made in space, power systems like photovoltaics, and rovers themselves. In this chart, we tried to estimate an idea of what the sprint masses would be for a period of about 10 years. So you can see we have for a sprint minimum and a sprint maximum. On the sprint minimum, we show the mass of the elements that would be on the surface and others that would be in orbit. Like, for example, we show that lunar base might be on the order of 700 metric tons, whereas in orbit, there may be up to 1,645 metric tons for the delivery systems to bring that 700 tons into orbit. Similarly, for the libration point, Mars and Jupiter, we provided those estimates. Just to show you where we've been, we discussed massless exploration, or the use of the vast resources available beyond Earth using in situ resource utilization. And we're hoping that these resources can allow human beings to flourish in many places beyond the Earth. Human exploration of the solar system is the next step beyond our current set of robotic missions. And we have used extensive capability of robots to gather data on mineralogical and chemical composition of other planets and their gaseous atmospheres. And using this data, we certainly are confident we can formulate plans that make these materials and resources able to sustain human life and bolster our exploration plans and hopefully preserve humanity.